Hello students, today we are going to do image formation by concave mirror. So our first case in this is when the object is placed at infinity. Okay, so let me put the first case in object at infinity. That is, object is far, far away. So let me make the object here. So my object would be black in color and I want you to notice something. So my object here is both above and below the principal axis. Okay, so this is the object here, the one in black color. Okay, now for the image formation, I need to have at least two reflected rays. And to have the two reflected rays, I need to have two incident rays. So my first incident ray would be the one parallel to the principal axis. Okay, so remember for most of our cases, we would have the first ray as the one parallel to the principal axis. So let's say this is my first incident ray. Okay, I will, for clarity, I will name it as I1. Okay, now the incident rays parallel to the principal axis gets reflected from where? We did it in the last video. They get reflected through the focus. So from here, I will draw a line. I'll draw a line through the focus. Okay, so like this. And I call it as R1. Okay, so my incident ray is green in color, my reflected ray is saffron in color. Now let's take the next incident ray. I'll use the green color again. I'll take the second incident ray also as one parallel to the principal axis. Okay, but it would be from the bottom of the object, or it will appear like from the bottom of the object. So it's below the principal axis also. Okay, so if you look at it, the principal axis here in the center is blue in color, and we have the two incident rays above and below. So now let me call my second incident ray as I2. Okay, so blue, this one, the blue middle line is my principal axis, the I1 is here, I2 is here. Now let me make a reflected ray for I2. Okay, so let's use the color amber again, and let me draw. It will go through focus only. Okay, okay, so your ray will not intersect. I mean, intersecting with the incident ray doesn't mean anything. For image creation, it has to be the intersection of the two reflected rays. Okay, okay, but we'll keep the rays shorter, and I will name this as R2. Okay, R2. Now, where do you think the R1 and R2 intersect? They are intersecting at the focus. Okay, so they are intersecting at the focus, and while drawing, ensure that this ray R1 is smaller and stays within the incident ray I2. Now let's say, where is the image location? It is at focus. Okay, what is the size? Highly diminished. See, the black line is so big, but the image is so small. Okay, highly diminished. And the next thing we need to know is real or virtual. We call it as real, okay, because the reflected rays actually, what happens? Intersect. And is it upright or inverted? Being real, it's inverted. Okay? And in the following diagrams, we'll see how. So this is the first case, object at infinity. We take an object which goes above and below the principal axis. The two incident rays that we take are both parallel to the principal axis, and we know these rays parallel to the principal axis get reflected through the focus, so they both get reflected through the focus and our image is formed at the focus. And the rest you can see, it is at focused, highly diminished, it's real and it's inverted. Okay, now let's move on to the next case. So, next case is where the object is beyond C. That is, it's further away from the C. It's not at infinity, but it's on the principal axis away from C, even further away from C. So, let me make a concave mirror and the principal axis. Yeah, so now we have a concave mirror and then I name my pole, we have focus and we have center of curvature. Now let's draw the object. So now my object is beyond C. So we have to go further and make an object. So we'll make an object now further away from C. And it will stay above the principal axis. The only time when it goes below the principal axis is either when it's at infinity or when it's at center of curvature. Okay? And no, none other time. So now this is my object in black. Okay, so you name it here object. Now we have to take two incident rays which get reflected. So like I said before, let's take the first incident ray as the one parallel to the principal axis. Okay, so this becomes my first incident ray. I name it as I1. Now, do you know where will it get reflected from? We had done it in the past. In the previous case, any incident ray parallel to the principal axis gets reflected through the focus. Okay, so let's make it through the focus and remember to put the arrows. Okay, beta. So now you name your reflected ray as R1. Now time for the second incident ray. So where should we make a second incident ray from? Now what we can do is we can take center of curvature only. So my second incident ray goes through center of curvature. Okay, and I name it as R2. I name it as R2. Oh, sorry, I2, incident 2. Now, where do you think it gets reflected from? Remember what we studied? It gets reflected back through the center of curvature, exactly on the same path that it came from. Okay, so I'll just make it back like this and I will name it as R2. Note the arrows. I2 is coming down towards the mirror. R2 is away from the mirror. Now, where do we see that these get intersected? Between C and F. So, let me make, I'll make the images red. Okay. So, we make a line between the principal axis and where these two reflected rays converge. Okay, so it's this. Okay, now what would be the sign of the arrow here? It's going to be down. Okay, so you make it at the tip of the object. It's not a ray that you can make it anywhere. So you make it at the end. So your object you see is inverted. You start from the principal axis, take the line down to the intersection of your two reflected rays. Now, so what do we notice? Where is our image located? It is between C and F. Okay. So if you have seen my previous video, you learn all the 4 rules and then it will be so much easier for you to do this. Okay. So your image is located between C and F. What is the image size? It is diminished, right? You can see this black line is this big, but this red line is so small. Okay. So it is diminished. Now, is it real or virtual? It is real, because we see at the intersection of the reflected rays actually happen. And is it inverted or straight? It is inverted. You see the arrow facing down, right? The object is above the principal axis. The arrow is facing above the principal axis, that it's trending this way, but the image formed is below the principal axis, facing down. So these are the 4 things for the object which is beyond C. Okay, again remember what are the 2 incident rays you will take so that you can make the image. You can take any case. I mean, you can again, take 1 through focus and see how it goes. But this is the one given in our book, and it's better if you follow this so that, uh, you get full marks. There's no ambiguity there. Okay, and remember to name your object also. Okay, so you name the object as A, B, and images A dash and B dash. So this way it is clear that it is inverted. Okay, head of the object is A, the bottom is B. The head is this and the bottom is this. Okay, so now let's move on to the third case. Okay, kids, our third case is the object is at center of curvature at C. Okay, so this C on the mirror, right? So the object is placed here itself. So let's draw our object, and like I said, I make it in black color. So this is my object here. I'll make it this big only. So let's put our arrow here so that we know this is the top, and let's call it as A, B. Okay. Now we have to consider 2 incident rays so that we get 2 parallel rays. Sorry, reflected rays. So my first incident ray would be the one parallel to the principal axis. Like I told you before, in most of the cases, that's what we do. We take the first incident ray as the one parallel to the principal axis. So I'm doing that. Okay, let me try again. So this is my incident ray. Let's name it as I1. And you don't actually have to name it. I do it so it's clear which ray is what. Okay, I call it as I1. Now, we have seen before in previous 2 cases, the incident ray parallel to the principal axis gets reflected through the focus. Okay, so now let's make the reflected ray. So my reflected ray is amber in color. Okay, so this is my reflected ray. I name it as R2. Now I have to take one more incident ray. And that incident ray, let's make it go through the focus. Okay. Now, do you remember if a ray goes through the focus, how does it get reflected? If not, we'll just see it in a moment. Okay. So, this is my second ray. I call it as I2. Okay. Now, where does it get reflected from? It's parallel to the principal axis. Remember, it was the reverse. If the incident ray is parallel to the principal axis, it gets reflected through focus. And if the incident ray goes through the focus, it gets reflected parallel to the principal axis. So let's make the reflected ray. I'll use amber color and I will draw it like this. Okay, let's put the arrows. This is my reflected ray, R2. Okay. This is R2. Okay. This was R1 and R1 and R2. Now where do they intersect? Let's see. They intersect at this point. Let me extend it. Okay. Let's give it a head. So you see it is exactly below the object. Let's call it as A dash and B dash. Okay. So when the object is placed at center of curvature, the image is also formed at center of curvature, but it is upside down, inverted. So what do you say? Image location. That's the first thing you should remember. It is at C. Size, same size. Okay. Real or virtual? It is real. Real, and it is inverted. Okay. Upright or inverted. It is inverted. So these are the three things about the image formed at center of curvature for the object placed at center of curvature. Okay. Now let's move on to the next case, which is our fourth case. Any guesses what the fourth case would be? Yeah. Now it will be between C and F. Okay, kids. Now let's do our uh, fourth case. So our fourth case's object is between F, C and F. Okay. Remember we started from infinity. Then we moved to beyond C, then to C, now between F and C. So let's make the object, and I will use a black color to make my object so that it stands out. Okay. So this is the object. Let's give it a head and a name. Okay. So okay. So the object is here and its name is A, B. Now, again, what is the first incident ray that we are going to consider? What is the convention I told you? We take the one parallel to the principal axis. So, I'll make this as my incident ray. And what do I call it? I1. Okay, now where will it get reflected from? We have seen in the past, in all the three cases in last video, it gets reflected through the focus. I'm drawing it large because I know why. So let me make the arrow here and call it as R2. Okay. So this is my sorry, R1, because I1 will have a R1. Okay. Now let's consider the other ray. Now it's between C and F. What do you think we should take the second incident ray as? Let's take it through center of curvature because it's going to be easy that way. Okay, so let's do that. So my second incident ray will go through center of curvature. And I'll extend it here. Okay, I'll extend. I'll keep it like this. Okay, so from this is the object and the incident ray is going from the center of curvature to the mirror. So I call it as I2. I should use green color. I2. Now, remember what happens when a ray passes, incident ray passes through the center of curvature? It gets reflected back on the same path. Okay, so let's do that. Let's make the ray get reflected through the same path. So what I'm going to do is start from the mirror, take it through here and extend it till it intersects with the other one. And I name this as R2. Okay, what do I name it as? R2. Because this is my second reflected ray. Now, where is the intersection of the reflected rays? Over here. Now, let's draw our image, the image formed. So, this is the image formed here. And let's give it a head. And so this becomes A dash and this becomes B dash. Now, what is that we observe here? This was my object. This is the image. Definitely it's bigger than the object. है ना? And where is it created? It is created beyond C. है ना? C is here and it's gone past C and is created here. It is inverted and it is real. So let's write this. Image location is at beyond C. Okay. Size. What is size? It is enlarged. That is, it is bigger than the size of the object. And it's real or virtual? Virtual, it is real. Okay, and then we know it is inverted. So is it erect or inverted? It is inverted because its head is down. It is inverted. Okay, so 4 things for this image. When the object is between C and F, the image formed is beyond C. It is enlarged, that is bigger in size than the object. It is real because actual intersection of the rays happen, and it is inverted. But being a real image, it's inverted. Okay, that means its head is down. Okay, this was our 4th case. We have 2 more left. So let's move on to our next case. Okay, now the fifth case. Where would the object be now? Object at F. Okay, so last and last it was between C and F, now it is at F. So let's make our object at F. So the object is here. Okay, now let's give it a head and let's give it a name A and B. Now, like we discussed before, the first incident ray that we take is parallel to the principal axis. Okay, so let me make that. So I start from here and I make it like this. Okay, and what do I name it? As I1. Where will it get reflected from? It will get reflected from the focus itself. Okay, so let's make a reflected ray for this incident ray. So I'm drawing it and I am extending it. I'll tell you why. Because you would see, you need to know that if it gets intersected somewhere. And I call it as R1. So for my I1, this is my R1. Now what do I take as I2? Let me take it parallel to the, let me take it passing through the C, center of curvature. Okay. So like we had done when we had placed the object between C and F. So this time also what we'll do is we'll make the second one go through C. So this is the head of the object. I'll take it like this. Okay. So now this becomes my second incident ray. I call it as I2. Now where will it get reflected from? Incident ray passing through center of curvature gets reflected back on the same path. Okay, so let me do it like this. Okay, if made correctly, it should never intersect. With the correct this thing, it should be parallel and it should go and get done at infinity. I'm just doing it like this. So, and why didn't I extend the green one below? Okay, so if you look at it, it's like this. Okay, so now my reflected ray, I'll delete and do it again. So the reflected ray will be on the same path as the incident ray, which means it's getting parallel and these will go and meet at the infinity. Okay, so remember this. This is R2 and they meet at infinity. I'll say at infinity. That is, we do not see the image formed. Now, let's write the stats for it. Image location at infinity. Infinity. Image size. What do you think the image size would be? Size. Image will not be formed. Why? Because at infinity we don't know if they would ever meet or not. Image not formed. So this is one place where the image is not formed. Always remember this. Object at focus will not have an image formed. Star this. This is a special case. So there is no like real inverted, real virtual, not applicable. Okay. and then erect, inverted, uh, not applicable. So this is a special case. Remember, object at focus will not have an image formed. This was our fifth case. Let's move on to the sixth one. And guys, remember that I was doing freehand, but when you make this, ensure that your C is your focus is in middle of pole and C. Okay? So that when you draw this and draw the mirror with the help of a compass, so that when you make the rays, they go exactly the way they should. If you do it freehand, there will be trouble, like I was facing in this particular case. Okay, so let's move on to the next case. Okay, okay, students, now let's come to case number 6, which is object is at, tell me, object is at between focal point and pole. Okay, so let's draw the object. I already have the mirror drawn to save us some time. So let's draw this object here. Okay, let's name it. Let's call it A and B. Now, what are the incident rays we'll take from here? We'll take here. Let's do that the first ray hits the pole. Okay, but my first incident ray would be this one. That is oblique to the mirror. Remember, there that was the rule number 4. So I take this here and let's name it as I1. So do you remember what happens when a when a ray, incident ray is oblique to the principal axis? It gets reflected oblique only, but on the other side of the principal axis. Okay. So let me make this as R1. Okay. So R1. Remember, this is the case where we haven't taken it parallel to the principal axis. We are taking oblique, the rule number 4. Okay, and my second case of incident ray would be passing through C. Okay, again, let me do it like this and let me extend it like this. Okay, so let me name it as R2. Sorry, I2. This is my second incident ray. And what happens? Okay, so 1 second, it has gone a bit up. I need to extend it a bit, okay? So let me do it like, it has to go through C actually. So it should, okay. This is the problem between, I'll just move my C, okay? Because it's not by the actual scale, so it's a little difficult to get it right. Okay. So now what happens? This is the C. This is C. Okay. Ah. This is C. Now this is my incident ray 2. What would be my reflected ray? It will be on the same path. Okay. Because incident ray going through center of curvature is reflected back on the same one. So Let me give it arrow and call it as R2. Now what do you think? Is it intersecting anywhere? No. So what we'll do is we'll extend it backwards. This one here and this one here too. So let me do it freehand only like this, and then this one like this. And what do you see? They intersect behind the mirror. So if you look at it, this was the mirror's back. Okay. So in our last case, when the object is placed between pole and focus. So this is why it wasn't working. Focus is here. Okay, scrap this. Let me do it again. Let me do this again. So let me make a mirror. Okay. This is the back side. And let me make principal axis. So this is the principal axis. Okay. Remember in this case, this particular, okay, the case is object between focus and pole. Okay. This is our last case, case number 6. So now let me make a principal axis. And in this case, we'll extend the principal axis on both the sides. Okay. Now let's name the pole. This is pole. This is F, focal point, and this is center of curvature. Now let's make our object. It is between it is between C and P. Right? So let me make it here. Okay, name it as AB. A and B. Now the first incident ray will take is oblique to the mirror. Okay, so let me make it like this, and it gets reflected like, okay, this. Oh, I don't need the reflection. Okay, this is oblique to the mirror. I call it as I1, and then it gets obliquely reflected through the mirror. I call it as R1. Okay, now the second one will go through the center of curvature. Now here, since it's not drawn to the scale, we'll have to see how we make it work. So I am making it like this. So this goes here. This becomes my I2. And what happens when the ray goes through center of curvature incident ray? It gets reflected back. Sorry, it gets reflected back on the same path. Okay, so this becomes my R2. Now R1 and R2 are not intersecting here. They will go beyond the mirror. Okay, so let me extend it like this, and let me extend it like this. So now what do you see? The image is formed. The intersection is here, right, over the principal axis. So where is the image formed? Image is formed beyond the mirror. Okay. Image is formed beyond the mirror. This is my image. I call it as A dash, B dash. What do you notice about the image? Location beyond, beyond mirror, or you can say it behind the mirror actually. Behind mirror. Size enlarged, right? It is bigger than the object. And is it virtual or real? Virtual or real? It is virtual because the reflected rays are not actually intersecting, right? We are extending it behind the mirror. And then the next is erect versus inverted. So what do you see? It's erect. So remember, most of the time virtual images are erect images. Okay, so if you see the heads of both the object and the image are at the same position, right? Upwards. So this was our sixth case. This is on page 140 of your NCRT. Remember these, it will be of help. And a question may come. Remember to use a compass to make a mirror, make it big enough, and a scale and a pencil, and to the measurements, F should be between C and P. Remember in which case which incident ray has to be taken. So the first incident ray is always the one parallel to the principal axis except for the last case. And then the second ray you will have to see which one is which is to be considered. In first case, it stays parallel to the principal axis. In the second case, it is through the center of curvature. In the third case, it is through focus. In the fourth case, it is center of curvature, then again center of curvature, then again center of curvature. Okay? So do learn this and see my previous video. So once you remember the incident rays, you won't have to remember the reflected rays. It will come easily to you where the object is formed. Good luck, kids, and have a good day.